This Friday. So if you're gone this Friday, huh? If you're gone this Friday, then you'll just take it Monday. Test is Tuesday. Quiz is 10 questions, multiple choice. Basically everything that we've covered up until today. Being able to classify reactions, being able to look and balance them, being able to tell me what is going on or what is a characteristic of a chemical reaction. Okay, so this problem here has 3 parts to it. You have to write the equation, balance it, and then classify it. So first of all, let's write the formula equation. So what is the formula for lithium oxide? Li2O. Breaks down. It's my verb, right?
Yep.
Into its component parts. What's its component parts? Li plus O2. All right, so we've gotten that far. The next step is to balance it. What? 2 oxygens on this side, so I need to put 2 over here. There's 2 oxygens over here, and so I need to put...
Oh, okay, I thought that was already... Okay, that's my fault.
All right. Okay, so next is what type of reaction is it? Decomposition. Number 2, methane combusts. This combustion. So CH4 plus O2, thank you. Plus O2.
And that's because it reacts with oxygen.
Has to react with oxygen for combustion. And we're going to get what products? And then we go back and balance it. How are we going to do that? Let's put a... Will it always what?
Like for whenever, if you say, for example, another, instead of methane, if you do something else,
Uh-huh.
will it still always equal CO2?
Mm-hmm. If there's a C in it, it always and then it has to always have CO2.
Okay.
If it has, so if we had something like this, C2H5OH, then we have to have carbon dioxide and we have to have water. Okay? All right, any questions on that? Okay, so what we're going to talk about today is called oxidation reduction reactions. So these reactions, we've talked about synthesis, we've talked about decomposition, we've talked about single replacement, we've talked about double replacement, and we've talked about combustion. So these reactions can further be classified as oxidation reduction reactions. So what is occurring in an oxidation reduction reaction, or what we like to call redox, is electrons are being transferred from one element to another. So electrons are transferred from one to another. If something loses electrons, it is classified as being oxidized. So we like to call that LEO, losing electrons oxidized. If one is losing electrons, something else has to gain electrons, and the one that is gaining is called, is reduced. So we call that GER. gaining electrons is reduced. But if we're in Texas and you don't like lions, then you can go with oil rig, where oxidation is losing, reduction is gaining. I don't care which one you use, whatever. You cannot have one without the other. You have to have both of them. So anytime we have a change in oxidation number, it's a redox reaction. So right now, let's just go ahead and ignore this. Don't write that down. We're going to come back to that. Are there any questions over this thus far? Leo goes GER, losing electrons oxidized, gaining electrons reduced, or oil rig. Oxidation is losing, reduction is gaining. How I like to also remember this is if something is reduced, their oxidation number decreases. Their oxidation number goes down. If something is oxidized, its oxidation number goes up. Huh? Kind of. We're going to talk about that in a minute. Any questions on that? So before we go into these reactions, I want to talk about oxidation numbers. Oil rig. Oxidation is losing, reduction is gaining. Everybody good? Okay. To determine an oxidation number, any free element, so any element in its form that includes oxygen, which is O2, or iodine, which is I2, or say potassium, any free element has an oxidation number of 0. In an ionic compound, the element's oxidation number is equal to its charge. So potassium, when it's in a compound, it has a +1 charge, which means its oxidation number is +1. Oxygen has an -2 charge in an ionic compound. That means its oxidation number is -2. So some exceptions here, just FYI, oxygen is always a -2. Hydrogen is always a +1. Unless it's a free element. If it's a free element, then it's 0. Now, in a covalent compound, what you need to do is to look at your most electronegative element. So that's usually the last one in the compound. And determine its charge. Once you've done that, then you can determine what the very first element is.
EN means what?
Electronegative. So that's the very last one. So if I had, say, carbon dioxide, or let's say carbon monoxide, I know oxygen is always a -2. So the oxidation number of carbon has to be a +2, because the sum of your oxidation numbers has to equal 0. Unless, in covalent on all bonds, unless it's an ion. And we're going to talk about that, a polyatomic ion. Okay, so let's go just get into it and do some of these problems. And this lecture will be up tonight. So I don't want to do this one. Let's just go ahead and I'm going to put NF6. What is the charge of fluorine? It's a -1. How many fluorines do we have? So that's a total of -6. So fluorine's oxidation number is a -1. So if the total has to equal 0, what does nitrogen's oxidation number have to be to get me to 0? A +6. Okay, this is, remember, I tell you, when we're naming these compounds and stuff, we don't care about charges. And the reason why we don't care about charges is because we're sharing electrons. That is what this is showing me, how we're sharing those electrons. All right? So this is an interesting one here. I know when I have something like this where we have 3 elements, I do my last one first. Then I do my first one, and then I figure out the middle. So I do it just like that. So oxygen is always a what? -2. And we have 4 oxygens for a total of -8. Hydrogen is always a +1. And we have 2 of them for a total of 2. So when I add these together, it has to equal 0. So what does S have to be? -6? +6. The next one, we have a polyatomic ion. So this is ClO3, and don't forget that minus right there. So this is a polyatomic ion. So first of all, oxygen is always -2, and we have 3 of them for a total of -6. And now we need to figure out what chlorine is. When I add these together, I have a negative charge, so it has to equal, not 0 this time, it has to equal a -1. So what does chlorine have to be? A +5. Okay, so if I were to do this, hydrogen plus chlorine gives me 2HCl. What is the oxidation number of free hydrogen and free chlorine? 0. What is the oxidation number of hydrogen in a compound? plus 1. What is chlorine's? Minus 1. Hydrogen went from a 0 to a what charge? Or what oxidation number? Plus 1. Chlorine went from a 0 to a
Wait, is it not plus 2? Is it 2?
negative 1. I don't care about coefficients right now. Whose number went down? Chlorine's oxidation number went down. So that means it is reduced. Hydrogen's oxidation number went up. Therefore, it is oxidized. Okay? So if your oxidation number goes up, you are oxidized. If your oxidation number goes down, then you are reduced. Yes.
So like, since, sorry, but like how oxidation is losing. So like, how does that work here?
Okay, on this one here? On the problem I just did? Okay, so good question. Thank you. So hydrogen is when we have free hydrogen, we have 1 proton and we have 1 electron. When hydrogen goes to a positive 1 charge, it has 1 proton, but how many electrons does it have? 0. So it has a plus 1. So it lost that electron, so that means it is oxidized. And if we look at chlorine, chlorine has 17 protons and 17 electrons for an oxidation number of 0. When we have chlorine with a minus 1, we have 17 protons, but now we have 18 electrons for a charge of minus 1. So it gained an electron, so it is reduced. Okay? So it's counterintuitive. So take a moment now, go and work these. No, next one in line. Caden. Good. Next we have H, C, and O. So what is the oxidation number of O? Minus 2. And we have 3 of them for a total of negative 6. Hydrogen's oxidation number is? And we have 2 of them for a total of positive 2. So therefore, carbon, only one of them has to be what? A plus 4.
So like whenever you have 3, you just have to make the middle one whatever it's gonna.
Yes. Use the middle one for last. Okay, here's a good example right here. Those of you that want to look at the periodic table and find GE's oxidation number. GE is on the stair step. It's touching the stair step. So GE is a metalloid. Metalloids will never act like metals. They won't take a charge like a metal will. So, again, we got to go to the oxidation state. So chlorine is minus 1, and there are 2 of them. So GE has to be a positive 2.
So you start with the CO?
Yes, the very last one, yes. So let's do this one and then we're going on. SO4 with a negative 2 charge. oxygen has a charge of, or a oxidation number of -2 for a total of -8. Whatever sulfur is, when it adds to oxygen, it has to be a -2. So it's what? It's +6.
Why does that have to be -2?
Because that tells me right here, this. All the time we're getting to 0, but if it doesn't have that charge, there, then we want it to be 0. But since it has that charge there, then we want it to be -2.
So doesn't that mean it has 2 more electrons?
Mm-hmm.
Where did it get those from?
Where did it get those from? It's because oxygen, there's an unbound pair there. It's just from,
Something else?
yeah. Okay. Any questions on that? So let's go to redox problems. Okay. So when we talk about redox, did I talk about what type of problem? Did I say that the synthesis, decomposition, all those will be redox? But okay, so that was my whole point of writing them up on the very first slide. Synthesis are redox. Decompositions are redox. Single replacements are redox. Combustion is a redox. Very seldom, so seldom do you have double replacement being a redox. All right? So double replacement, not very often will you see those being redox. Did I spell seldom right? That just looks really weird. Okay, so let's look here. So when you're trying to determine what is going on, the very first thing you need to do is go assign oxidation states. What's the oxidation state of any free element? 0. So all these, 0, 0, 0. So I can go get those. I know those are easy. Those are zeros. Then I go and I look, my nonmetals, or my ionic bonds. Their oxidation numbers are equal to their charges. So what's the charge of aluminum? Aluminum's a +3. What's the charge of sulfur? -2. So now, all I'm going to do over here on the other side is I'm going to say that aluminum goes from a 3+ charge to a 0. Sulfur goes from a 2- to a 0. So whose charge went up and whose charge went down? Whose charge went down? AL's went down. So it is reduced.
Wait, I have a question.
Hmm.
Does it matter which one you put in which
No, it doesn't matter.
Okay, I thought you just...
No. This is just added in there. So then that means sulfur, its oxidation went up, so it is oxidized.
Oh, yeah.
So go do it for the next one. PB and S. Sulfur's charge is always a, this is a ionic compound, so sulfur's charge is a -2. So lead's charge, or lead's oxidation number, has to be a +2.
So those other numbers don't matter.
Coefficients, we're ignoring coefficients. So over here, oxygen is always this is a covalent bond, so oxygen is always a -2. So sulfur has to be what here? Not +2, because we have a total of -4.
Oh, +4.
+4. Oxygen's a -2 here, so lead has to be a +2. So when you're looking at this, whose charge stayed the same throughout the whole thing? Lead. Lead. So lead's not going to be oxidized or reduced.
Sulfur.
So sulfur goes from what?
-2.
A -2 to a positive 4. And oxygen goes from a 0 to a minus 2. So whose number went down?
Down
Uh-huh.
was oxygen.
So oxygen is reduced.
Sulfur here, oxidized.
So the other one has to be oxidized. Next. Oxygen's charge is a negative 2. Hydrogen's is a plus 1. So hydrogen goes from a 0 to a 1. Oxygen goes from a 0 to a minus 2. So which one, whose number went down? Oxygen. So it is, therefore hydrogen is oxidized. Questions? So I want to do one more and then I am done. Okay. I'm not doing any of these right now. We're going to, this will be your bell work tomorrow, so should you like to work in advance. I want to take a look at a combustion one real quick. CH4 plus oxygen gives me carbon dioxide and water. So we need a 2 there, a 2 there. So we know that oxygen's oxidation number is 0 here. It's a minus 2 here, minus 2. We know hydrogen is always a plus 1. This one's a plus 1. So here we have a total of plus 4. So what's carbon's number here? Minus 4. Here we have a total of minus 4. So what's carbon's number here? Plus 4. So whose number changed? Oxygen goes from being 0 to a negative 2. And hydrogen, or not hydrogen, carbon goes from being a minus 4 to a plus 4. So, who's oxidized, who's reduced? Okay? If you need to, draw a number line. I have my negatives and I have my positives. Put a 0 here. If you're moving up this way, up the number line, then you are going to be oxidized. If you're moving this way, down the number line, then you are being reduced. Any questions over that? So there is no homework tonight. So I am done. This lecture will go up on homeroom for those of you that need to go back and review it.